Hey guys, Mr. Bowman here. Today's learning objective is up the top, and we are learning to identify the formula of given trig graphs. And then I've got the key thing, but in radians. So today is the day we learn what is actually the difference between radians and degrees and how that affects our mathematics. So we've been working with our trig graphs, and I've got a sine graph here and a full cycle started and finish within 360 degrees. And what I want us to do is I want to link this 360 degrees. I want to link that to a circle. So I've got an angle, and a full rotation of that circle is, you bet ya, 360 degrees. But I want us to think about a circle in another way. Let's have a think about the circumference of this circle instead. So hopefully you remember that the circumference is equal to 2 pi r. And if you think about this this sine graph or this circle, all of them relied on the idea of having a maximum of 1. So what that meant was the radius of those circles was actually 1. So if we put a radius of 1, so that will be 2 pi times 1, and that comes to 2 pi. And this idea, a full rotation is actually 2 pi, is what we know as radians. So during the exact same trig graph, a full rotation would be 2 pi. So when you're dealing in degrees, well, you bet you that's in degrees mode. That makes sense. And when you're dealing with versions of pi or rotations around the outside of the circumference of it, you betcha that is radians. And then, like other parts, the halfway point of our degrees graph, well, that's 180 degrees, and half of 2 pi is pi. The peak of that sine graph, well, that would have been 90 degrees, or a quarter. So what that would have been 2 pi divided by 4, which comes to pi over 2. And that peak there, well, that would have been 270 degrees, which would have been 3/4 of pi, which would have been 6 pi over 4, which comes to 3/4 of pi. So that's the difference between degrees and radians. And what I'm going to do is I'm going to pause the video. I'm going to write up some examples. We do want to practice converting between degrees and radians prior to getting into some graphs itself. So I'm going to pause the video. If you haven't got these notes about degrees and radians, please get them down because it is really important. Okay, I've cleared all that. I'm just going to draw another graph just to help us with the next part. So there's another sine graph, and we figured out the full revolutions happened in 360 degrees or 2 pi. So what we know is 360 degrees will be equal to 2 pi. So our step is we now need to know, how do we go from radians to degrees, and how do we go back from degrees to radians? Okay, let's change pen colors. Let's switch to blue. And what we're going to do is we're going to start off with going from degrees to radians. So let's say we've been given 270 degrees, and we want to know how many radians that is. What I'm going to do is I'm going to divide that by a full revolution, which is 360, and then I'm going to times that by 2 pi. And when we did that, 270 divided by 360, well, that's going to be 3 over 4 times 2 pi, which is going to become 6 pi over 4, which is going to become 3 pi over 2. And that would be the radians of 270 degrees. So what we do is we find the proportion of 360, and then we times that by 2 pi, and that gives us our final thing. So let's have a look at more of a weirder example. So sometimes it's not a nice, easy fraction like that. So let's say we're looking at 67 degrees. So how would we find that into radians? So what we're going to do, 367 divided by 330 degrees times 2 pi. When it's not nice like this, what we do is we're actually going to convert it to a decimal version. So we're going to get 0.1861, and I've rounded that to 4 dp. We're going to times that by 2 pi. And so 0.8161 times 2 pi, and that's going to become 1.1693 radians. And I've got that to 4 dp. So it doesn't always have to be in terms of pi, but when we can, we should be aiming for that. So what we've done is we have rounded that as well. So that's how to get from degrees to radians. Let's change pen colors. Let's think about how do we go the other way from radians to degrees. And it's a very similar process. So what we're going to do is, let's say we've got, so we're going to use, let's say we got 0.4 of a pi. That's the radians that we have, 0.4 of a pi, or 4/10 of pi. Well, that needs to be divided by 2 pi to figure out the proportion of a full cycle. We're then going to times that by 360. So that's the opposite here. So we had 360 there, but we're timesing it by 2 pi there. And what that's going to get us is, apologies about the glitch there, so that would be 0.4 over 2 times 360. And 0.4 over 2, that comes to 0.2, and 0.2 times 360, that's going to get us to 72 degrees. And we'll do one more example. So let's say we've been given a weird number like below. So let's say we've got 3.9214 radians. What we need to do is we need to find the proportion of a full cycle by dividing it by 2 pi. And we need to times that by the unit we are looking at. I'm going to put that onto our calculator. So 3.9214 divided by 2 pi. Well, that comes to 0.6241, and I've rounded that to 4 dp, and that's going to be multiplied by 360. So 0.2641 times 360. Well, that's going to tell us it's 224.676, or 224.7 degrees, and that was rounded to 1 dp. So what we've done here is we've converted back and forth between degrees and radians. The key thing I want to recap, just changing pen color to yellow to help us with our recap. When we are switching from degrees to radians, we need to be doing a proportion of a degree times the radians that we're looking for. Proportion of the degree times the radians that we're looking for. And when we're going from radians to degrees, they are the opposite round. Our proportions are out of 2 pi, and we are timesing it by the degrees to convert to a full revolution. So hopefully you found this video on converting between radians and degrees. This skill is really, really important for when we try to calculate the formula of given graphs, but when we're working in radians. Now let's get into some conversion type questions.